Hey guys, I am going to be doing 4 different subjects for the rest of the year regarding math. We're going to do 2 lessons on dividing decimals, and then a handful of lessons on fractions, and then a few lessons on graphing and geometry. These are all the things that we were supposed to touch on before the end of the school year anyway. I'm just going to make them smaller lessons and give you the basics for them. Then when you move on to 6th grade, your teachers all already know that we were on quarantine and we missed school because they're missing it too. So they will hopefully go back and give you some lessons regarding these things as well. So with that being said, let's get started on division. I'm going to take a step back and just kind of go over the basics for division. So those of you who have not forgotten it, sorry. For those of you who may have forgotten it, listen carefully. So the steps to a division problem, the process that we use, we're first going to divide, then multiply, then subtract, and then we're going to bring it down and bring it back. So what that's going to look like is if we have the problem of 512 divided by 8, we currently have 2 parts. This here is the dividend. Whoops. And the dividend is the number that's going to get split up. Over here, we have the divisor, and that's how many groups we're looking for. Up here is going to be the quotient, and that's going to be our answer. It's also going to tell us how many of those things are in each group. So let's say we're talking about rocks. We want to divide 512 rocks into 8 groups. How many rocks are going to be in each group? That's what we're looking for, okay? So I'm going to get rid of these extra pieces here, and I'm going to work through it. So my answer is going to be in red, and I'm going to refer back to this process for all of it. So the first thing it tells us to do is divide. 5 divided by 8. Can we do that? Another way I like to ask it is how many times can 8 go into 5? And that's a big fat nothing. It can't. It's too small. 5 is too small. So I'm going to put an X on top. And then I'm going to slide over to my next number, which is a 1, making my new number 51. Now I'm going to start back at the beginning of that process again. What is 51 divided by 8? Well, that's not exactly even, right? So I'm going to tally just because it's been a while since I have been working on division. So I'm going to count by 8. 8, 16, 24, 32, 40, 48, 56. All right, 56 is too many, right? So I'm going to get rid of that last one. And I'm going to see here now I have 6 tallies. And I'm going to do my next step, which is multiply. 6 times 8 is 48. And 48 is going to go right below 51. And now I can subtract. What is 51 minus 48? I'm going to borrow. 5 becomes a 4. 1 becomes 11. 11 minus 8 is 3. Okay? Now, I subtracted. The next part is bring it down. 8 is less than 3, so I can bring down the next number, which is a 2. And I'm going to go back to the beginning. What is 32 divided by 8? And again, I'm going to count by 8. 8, 16, 24, 32. I got that one right on the nose. And there I have 4 tallies. So I'm going to put a 4 here. 4 times 8 is 32 exactly. And I can subtract 32 minus 32 is 0. Now I subtracted, the next step is bring it down, but we have nothing to bring down. So we're done. We have nothing left over. It went in evenly. And our answer is if we divided 512 rocks into 8 groups, there would be 64 rocks in each group. Now I'm going to do the same thing, but this time it's not going to be so pretty. I'm still going to use this process over here. Just get rid of that big red arrow. And I'm going to do the problem 512 487 divided by 4. Let's stay on the topic of rocks just because. If I have 587 rocks and I want to split them up into 4 groups, how many would be in each group? Okay, so switch back to red. How many times can 4 go into 5? And the answer is once. 1 times 4 is 4. 5 minus 4 is 1. And 4 cannot go into 1, so I need to bring my next number down. My new number is 18. How many times can 4 go into 18? Here I'm going to count by 4s. 4, 8, 12, 16, 20. Okay, 20 is too high, so I'm going to get rid of that last tally mark, and I have 4. So I'm going to put the 4 above the 8. 4 times 4 is 16. And now 18 minus 16 is 2. I'll put my 2 down here. 4 cannot go into 2, so I'm going to bring the 7 down. And my new number is 27. A little bit smaller. Here we go. Nice. I'm learning how to use this new platform. All right, so now, again, how many times can 4 go into 27? Well, I'm going to count by 4s again. 4, 8, 12, 16, 20, 24, 28, 32. Okay, 32 is too high, so I'm going to get rid of that one. And I have 7 tallies there. So I'm going to put a 7 above that 7 inside the bracket. And 7 times 4 is 28. Uh-oh, I've made a mistake. Did that on purpose. So I want to go back, and I'm going to subtract one of these because that's too high. I can't subtract 28 from 27. There's not enough. So instead of this being a 7 now, I'm going to make it a 6. 6 times 4 now is 24, and that is not too small or too big. And 27 minus 24 is 3. Now, we have something new here, and it's that the fact that there's a 3 at the bottom. What do we call this? A remainder. This is the remainder. And what that tells us is that we have some left over. So if I had 587 rocks and I put them into 4 groups, there would be 146 rocks in each group, and then there would be 3 rocks left over. So if I was splitting them between friends, I'd have to figure out what to do with that, because you can't just break a rock in half, most rocks anyway. But would I just leave them off to the side? Would I keep them for myself? Would I share them? That's kind of where you have to spend some time thinking about what you would do with a remainder. But a remainder is when you have something left over. Okay? All right, so let's go ahead and look at the first step. We're going to be looking at dividing decimals. We're going to be looking at patterns, and that will be here. Okay. And that's going to go right on the page for me. And I think, nice, I can just write right on it. All right, so when we're looking at patterns in decimals, if you remember back to when we were multiplying, if you did 4 7/10 times 1, it stayed 4 7/10. Well, 4 7/10 times 10 became 47. And then 4 7/10 times 100 became 470. The decimal continued to move to the right. Well, as we're doing division here, I want you to pay attention to which way the decimal moves. Hint, hint, it's the opposite. It's to the left. Okay? And again, I want you to just take this as slow as you can and get it at your pace. If you have any questions, call me. Your parents should all have my number. You can probably get a hold of me on Seesaw. And I will I will help you the best that I can over the phone. Let me get my page back up here. Perfect. Slide it over. Okay, so if you look here, it says to divide a number by 10, 100, or 1000, use the number of zeros in the divisor to determine how the position of the decimal point changes in the quotient. So let me see if I can. I was hoping I could make it a little bit bigger, but it's not letting me. But here we have 147 divided by 1. And we should all know that that's going to stay the same. But if you look here, there is a 0. There are no zeros in the problem. And so that the decimal that you really can't see, that decimal is actually right there. That decimal that you can't see, it's not going to move. It's going to stay right there. The answer is going to stay the same, right? Stay the same as the first number. Now, if we were going to divide 147 by 10, let's take that example of rocks again. If I had 147 rocks and I wanted to split them between 10 people, how many rocks would each person get? Well, the decimal is going to move one place to the left because in the number 10, there's 1 0, okay? So the answer then becomes 14 7/10. Now, if I'm going to take those 147 rocks and divide them among 100 people, there are now 2 zeros. And so it's going to move 2 places to the left. And then if we're going to go up to 1,000, people wouldn't even get 1 rock, right? But with 1,000, there are 3 zeros. So the decimal is going to move 3 places to the left. So let me go over that one more time with the exact same number there. I keep deleting the picture. My apologies. Perfect. Okay, I'm going to work over on the right here. So 147. And right now, where is the decimal? I don't see it. Well, it's right after the 7. And the number that would go after, that is a terrible decimal. Jeepers creepers. There we go. That's a little better. Would be a 0. Would go right afterwards, right? 147 and 0/10 is the exact same as 147. Think about it like money. You could write this $147, or you could write it $147. Either way, it'd be nice to have an extra $147, wouldn't it? Just to prove a point, though, it doesn't really change. It doesn't change the value of it. Okay, so now that decimal is staying right there, even though I'm getting rid of it. And if I were to divide it by 1, it would stay 147. That does not say 147. 147. Okay, if I were to divide it by 10, the decimal is going to move 1 space to the left. So let me get rid of this. And I'm actually just going to take that decimal there, and it moves in to here. And now I have 14 7/10. Changes it quite a bit, right? What did you notice? The number gets smaller, doesn't it? So when you're dividing a whole number by powers of 10, your answer is going to get smaller, obviously. Now, if I take 147 and I divide it by 100, how many zeros do I have? 2 zeros. So I'm going to start here where the decimal is, and I'm going to go 1, 2. 2 spots back. My new number is now 1 47/100. Okay? And then the same thing's going to be true for 1,000. If I have 147 divided by 1,000, the decimal is going to move 3 spaces because 1,000 has 3 zeros. Okay? So that decimal starts here and it goes back 1, 2, 3. And I'm actually going to put a 0 in front just because it helps me. If it doesn't help you, by all means, don't put the 0. Helps me, okay? All right, so now let's look at it if we were doing it with exponents, okay? 10 to an exponent of 0 is 1. 10 with an exponent of 1 is 10. 10 with an exponent of 2 is 100. Remember the little cheat that I told you in class? The exponent is the number of zeros when it's on a 10. So if you had 10 with an exponent of 5, it would just be 5 zeros, and then put your comma appropriately. So 100,000, okay? So let's look. That's not the eraser. Let's look at the example on the bottom of this box here. It says to divide a number by the power of 10, you can use the exponent to determine how the position of the decimal point changes in the quotient. And again, you're going to look at how many zeros, what the exponent is. So if I had 97 and 2/10 divided by 10 to the 0 power, don't forget that actually means 1. So 97 and 2/10 divided by 1 is still 97 and 2/10. It doesn't change. That decimal is going to stay in its place. But now, if I divide it by 10 to the first power, or 10 with an exponent of 1, there's 1 in the exponent. So that decimal is going to move 1 place to the left. And my new number would be 9 and 72/100. Okay? Now, if I was going to divide 97 and 2/10 by 10 to the second power, or 10 with an exponent of 2, that 2 there tells me that the decimal is going to move 2 places. So 1, 2, and now the decimal is here, and my new number is 972 thousandths, okay? What I would like for you to do is go to you can stop this video and you can go to the worksheet that has the patterns. Do whichever one looks like it's going to help you the most, but do one. If you want to do both, do both. Parents, they don't have to do both. They know which groups they were in and can do whichever worksheet they feel most comfortable doing. If you want a suggestion from me, text me, call me, and I'll get it all set up for you. Okay? All right. So I'm going to clear all of this, and I'm going to bring in a new image, if I can find it. All right, so this one now is talking about dividing by whole numbers. And actually, I don't want this one. That's the second one I need to use. I want... Guess that is the one that I want. Oh, this is the one I want. Okay. Okay, so this one here has it set up so that when you're dividing by a single digit divisor, okay? So the number that they have here is 5 and 68/100 divided by 4. And you can see each step is there. I'm going to talk through it just because I don't have you in front of me. I'm going to discuss this one like it's money because $5.68 is very familiar to me. And so I am going to divide the same exact way. I'm going to change this to red, and I'm going to show you what needs to happen, okay? So first thing we do, 5 divided by 4. How many times can 4 go into 5? And the answer is once. 1 times 4 is 4. And then we can subtract. What is 5 minus 4? It's 1. Okay? Then we bring down the next number, and our new number is 16. How many times can 4 go into 16? Hopefully you said 4. 4 times 4 is exactly 16. So I'm going to subtract 16 minus 16, and I have 0. And I still have this 8 here that I have to bring down. So it's just 8 that I'm looking at bringing my number down to, okay? So how many times can 4 go into 8? Hopefully you said twice. And 2 times 4 is exactly 8. And we have 0. Okay. Now, the nice thing about dividing with decimals is when you're dividing decimals by a whole number, all you have to do is push the decimal up into your quotient, and you have 1 and 42 hundredths. Okay. Now, if this were money and I had $5.68 and I had to share it between me and my 3 siblings, so there's 4 of us, each of us would get $1.42. Okay, that's how that works. Now, it's a little tiny bit different. Let me get rid of this. When you're dividing by a double-digit divisor, and that's the first one that I accidentally pulled up. Let's look at that. Okay. That's here. And so we're going to do the exact same thing as what we just did. I'm going to walk you through this one so you can see it, okay? Now, it does say estimate right here. You guys know I was pushing estimating. I am going to kind of breeze over it. It is still important, but for process purposes, I'm going to skip over it. So here we have 19 and 61 hundredths divided by 37. Okay, so how many times can 37 go into 1? Hopefully you said none. Put an X right there. So now my new number is 19. 19 is still less than 37. So how many times can 37 go into 19? Again, none. I'm going to put another X there. Okay. Now, my new number, even though there's a little decimal stuck in there, is 196. How many times can 37 go into 196? For me, I have to do some work on the side. So what I'm going to do is I'm going to start kind of estimating. I know that 37 is close to 40, and 40 times 5 would be 200. That's a little too high. But I know that 37 is a little bit less. I'm actually going to start, just to be safe, with 37 times 4. 4 times 7 is 28. 4 times 3 is 12. Plus 2 is 14. So we have 148, and that's pretty small compared to 196. So I'm going to find some extra space. I'm going to do 37 times 5. 5 times 7 is 35. 5 times 5 is 15. Plus 3 is 18. Now 185 is pretty close to 196, so I'm going to use it. So I'm going to take the 5 here, and that 5 is going to go up here. And what is 5 times 37? 5 times 37 is 185. And I'm going to subtract that. 6 minus 5 is 1. 9 minus 8 is 1. 1 minus 1 is 0. Now 37 cannot go into 11, so I know that I did it right. And I can bring down my next number, which is 111. And now I'm going to have to look. Okay, it can't be 4 because 4 was 100. It can't go in 4 times because 4 times would mean it would equal 148. So it's going to be less than 4. And I'm going to now multiply 37 times 3 and see what I get. 3 times 7 is 21. 3 times 3 is 9. Plus 2 is 11. And check that out. I get the number I need. So I'm going to take this 3 and I'm going to put it up with my 5. 3 times 37 is exactly 111, nothing left over. Okay. So now the very last thing that I need to do is that I need to push my decimal up, and I now have an answer of 53 hundredths, and that would look like this. That's how I would write it. Okay. So what I'd like for you to do is I'd like you to check out the two worksheets that I put on, and you can choose to do whichever one makes you feel most comfortable. And then if you'd like to do both, you can, and then just submit them on Seesaw. I hope that this was something that you were able to listen to. Please let me know if you have any feedback, and I'd be more than happy to help you. Okay.